Okay, so that was exciting. Hey everyone, what's a to the 0 power?
Nothing.
One.
Or
One.
that's on the
Get on your game.
I was thinking that we crossed that out, so it was nothing. But
No, it's a 1. Hey everyone, what's 26 to the 0 power? Thank you. Okay, we're getting crazy. We're getting wild and crazy here. Hey everyone, what's I really can't get too crazy with this. What's 1,296 to the 0 power?
1.
Okay, yep, okay. Hey everyone, what's 3x to the 0 power?
1.
No.
3.
3.
It's 3. I was trying to trick you. Kind of like up here, so I just wanted to kind of point out, sometimes we get into like a zone here. Remember that 0 only goes with the x, so this turns into a 1, and 3 times 1 is 3. So just be careful. Exponents, especially when you have a lot going on, it's just very important to remember that exponent only goes with that base. It doesn't go with everything. So just be careful with that. All right, let me do, we don't have enough of them. Do a million of these because they're all going to look very similar. But let's try this one. Ooh. How about we do, what if I said what's 5 to the negative 2nd power? I would say a good 60% of the time, even after I tell you how to do this, people just like, this is one thing that just like hurts our brain for some reason. People will say, people will say negative 10, which just hurts my heart because 5 squared isn't even 10, but people will say negative 25. That is not the answer. Okay? Think about what this is saying. This is saying we have a base, no matter what it is, it's a 5, whatever, that's fine, to a negative exponent. So to remedy that, to take care of that, we are going to flip this. So here's what I do. Okay, I'm going to take this, I'm making a fraction, and I'm going to flip it. Because that's what a negative exponent means you're going to do. That now gives me 5 squared, because when I flip it, it makes it positive. Hey, if I have nothing on the top, what should I put? 1. Okay, you never want just a blank numerator. That's kind of weird. So if you put something and there's nothing left there, you throw 1. And now we see, oh, I know what 5 squared is. It's 25. So just remind yourself, put it somewhere back in your brain ski here. When you have a negative exponent, it doesn't just make things negative. A negative exponent makes things into a fraction. Okay, so it doesn't change signs. It changes into a fraction. So just be careful. Because we will see numbers pop up. I feel like sometimes we're more comfortable with variables than we are with numbers, which is weird because we use numbers the most. But just as a heads up there. Let me just do 2. I'm going to do 1 more and then I'm going to have you guys try 1 or 2. All right, so last one. If I gave you something like this and I said simplify, all exponents should be positive. Let's do a to the negative 3rd. B, C to the negative 4th, D to the 7th over, E to the negative 9th, F to the 3rd, G to the negative 2nd. Okay, I'm just going to give you a second to write it. I was trying to write a little bigger. If you can't see, just let me know. Sometimes I forget with exponents and then tend to write small. All right, I don't see any zeros. Okay, so I just kind of do like a quick check. What do I see? No zeros. So the only thing we need to know how to do is the negative. So here's what I do. I go through and I find all negative exponents. This is a negative. That has a negative. That has a negative. And that has a negative. There's a bunch of them. And we said to make a negative exponent positive, we flip it. So this A, it starts in the numerator. I'm going to flip it down. This C is going to flip down as well. Hey guys, if something's in the denominator, what should we do to it?
Make it positive?
No.
Flip it.
Flip it, yeah, just always say flip it. That's always going to be the end. Flip it. Now, exponent, or this can get kind of annoying just because you see so many bases. we try to write things in alphabetical order, just so our answers all look the same. So when I say that, here's what I do. I just kind of go in order anyways. So A, I'm gonna flip down and become positive. I'm just gonna go through kind of each base. Okay, so A is flipped, okay, we're good. B is gonna stay where it is. C is gonna flip down and become positive. D is gonna stay where it is. E is gonna flip up, so I'm just kind of adding it onto the end there. F is gonna stay where it is. G is gonna flip up. And now, my friends, I have my final answer. So is it like the hardest work? No, because you're just moving stuff. It's more just, once again, staying organized is the big thing here, because there's a lot going on. So I'm a circler. When I see those negatives, I remind myself why I'm circling them. I'm circling them because I have to flip the side they're on. And I literally just go through base by base. I start here and say, what do I do? Flip it. What do I do? Stay, flip, stay, flip, stay, flip. Okay, so I'm going to have you guys try one, and then we're going to look at one other property for today, which is exciting stuff. I'm just trying not to rush people in case you're still writing. Just don't want that anymore. Okay, so you guys try this one. I gotta take attendance anyways.
Can you please simplify the following? And that's gonna be,
Ooh. 4 to the negative third. Let's use some different, I feel like I always use ABC. Let's go, Hij, K, M to the negative third over N to the 0. Oh, I don't want P to the fourth. I don't really like Q's. R to the negative fifth. Okay. So in general, if I said, hey, can you simplify that? You know 2 things to look for. Is there a 0 exponent? Because I can turn that into a 1. And then are there any negative exponents that I am going to flipperoo? So can you see how far you can get with that one right now using those properties? And I'm going to do attendance in the meantime. I think I actually see who's here.
So, here we go. 60.
Give me about 30 more seconds. All right, let's check and see what you got. So once again, stay organized. Don't do anything to this yet. This means I have to flip it. Don't start trying to figure out what the actual numbers. Gotta flip it. This turns to a 1. And gotta flip that. Okay, so I kind of just, once again, I just kind of go in order and either move or keep it where it is. So this gets flipped down. This stays where it is. This gets flipped down. Okay. Remember, when I flip it, it turns positive, so just as a heads up. This 1, I don't really have to do anything to. I mean, I feel like sometimes when you add 1s, it's more confusing. So you're like, what do I do with this 1? Remember, I'm just multiplying everything by 1, so that's why I kind of just cross it off. You don't really need it unless there's nothing there, but we have plenty of stuff here to take care of.
So you don't put the N anywhere?
Nope, so there's no more N. It technically turns into a 1, But once again, 1 times anything is just whatever's left, so you don't really need to write it. So you don't see me, I just kind of cross it off.
Okay.
The only time you'll really need it is if there's nothing else, you have to write a 1 as an answer, but if you have other stuff, you're kind of good. You got the P stays where it is, and then the R is gonna flip up. Okay, so I'm feeling pretty good, or I'm feeling pretty good, I don't know about you guys, but see how you did, because remember, this was introduced about 20 minutes ago, so if we're not pros yet, that's fine. Just kind of getting used to this stuff. I'm not done. And the only reason I'm not done is if you have number bases, you have to simplify them. Hey, do you guys know how to do exponents on your calculator?
Yes.
Does anyone not know how to do it? I'll do a quick, I'll throw mine up in a second just to show you. Because I'll show you a lot of shortcuts this chapter with calculators. I'll show you later how to do all fractions on calculators. That will be a good one. But knowing exponents is going to be super important. So 4 to the third, so 4 times 4 is 16 times 4 is 64. Can someone confirm that 4 to the third power is 64?
Yes.
Okay, thank you. I didn't want to write it wrong. So one thing I wanted to show you, how do I want to do this? That's going to be the easiest for everyone. Actually, hold on. I just want to throw my calculator up so you see it. And then I can show you different calculator. Like, why can they just not make one calculator, that has the same buttons? So some calculators have different buttons, but they mean the same thing. That's such a pain in the butt. But knowing how to use your specific one is going to be important because, who really wants to do this in your head all the time? Definitely not me, I can tell you that much. Sorry, it's always like a puzzle trying to get everyone to be able to see the same thing. Which is like the story of my life. Okay, so I want to show you guys my Hubcam. And then I'll project that up. Okay. Give me 1 second, I just want to show you the calculator stuff. Once again, I try not to assume you guys remember stuff, because last year was such a disaster anyways. I can barely remember last week at this point. Sorry, I'll take a second just to make it a little bit brighter. So I'm going to show it to you on 2 different calculators that I have. Yep.
I'm going to the bathroom.
Absolutely. So here's Calc 1. And then where's my graphic calculator? I have this one as well. Okay, so I have 2 calculators. They do the same things, but they have different buttons. So if I wanted to do 4 to the third, please do not sit here. I turn it on, and do 4 times 4 times 4. No, don't do it. Because when I eventually give you something, something weird, you're not going to want to sit there, you're going to lose your account. It'll be your thing. So on this calculator, to do an exponent, actually, I do have the same buttons. Well, never mind. That's kind of silly, but I'm going to hit 4. And then this button right here, I don't know why it's called a caret button, but it's called the caret button. Or that's what my teacher called it, and when I went to high school, so I keep calling it that. And everyone I know calls it that too. So it kind of looks like something's being raised to, so that means raised to an exponent of 3. Then we'll give you 64. So if I wanted something like 5 raised to the 8th power, not something you want to sit there and do 5 times 5 times 8 times, that gets annoying. You press enter and it's something super huge, because once again, exponents make things really large when you start multiplying it. So this one, I actually have the same button, right? I have my caret button right there. Some people have a button, it looks like an exponent, so I'm trying to think if I have any other calculators handy. Well, anyways, if you can't find your exponent button, you let me know, okay? I'll find it for you. You shoot me a pic of your calculator or let me see in class. But please, I'm going to tell you right now, in the past, it's you're home, you're doing your thing, whatever. You're here sometimes. We haven't super needed a calculator. I haven't given you crazy things. You will need a calculator this chapter. So if this is something that you've been putting off, I suggest that you get it soon. This one, this is the standard TI one. I don't know why, it's Cal. The school bought the cheap ones, which is fine because calculators all work the same as long as there's batteries in them. So I've gotten ones, the scientific ones that look like this, for $4 at Ocean State Job Lot before. You can get them at CVS for like 10 to 12, you can get them at Target. They're not super expensive. You do not need one like this. I mean, this is an old school graphing one, those are like $100. You don't need that. So stick to as long as it says scientific, you're good. And if it can say 2-line, those are the better ones, because you can kind of see 2 things at once. But once again, this is my exponent button, it looks like it doesn't even look like a carrot, I don't know, I need to look up the origin of why you call it a carrot. Or some people's, yours will actually just look like an exponent, use that. So if you're confused in the meantime, let me know, but your calculator is going to be your friend, especially once we get into some higher numbers that you're definitely not going to want to do in your head. And one thing I also suggest about calculators is just know how to use them. Because, maybe you're taking an in-class assessment next time we have one. I'm not giving you a calculator tutorial during an assessment, so just a heads up. Know how to use it before. Okay. We're just gonna do one more quick thing. As of right now, knowing that we're gonna use these more, and obviously we've just introduced, but are there any major questions about these 2 properties? These are the ones they pop up all the time, so you just have to kind of keep an eye out for them. That's why we start with them. Because once again, the negatives you see a lot because you have to flip them, and then the zeros kind of just pop up now and then. All right, so we're going to do one more. We'll kind of start it today and won't bring it into the end of the week. Can anyone guess? If I said, so I'll do the property in a minute. If I said, what is x to the 3rd times x to the 5th, what do you think it would be?
X to the 8th.
X to the 8th.
X to the 8. Wait. Yeah, X to the 8.
Oh, you said
Yeah.
X to the 15th.
15th. Yeah, sometimes I feel like make it a little easy. So we're just gonna think logically, then we'll write the thing. X to the 3rd means x times x times x, right? We obviously don't want to write it out the long way every time, but just to kind of visualize what's happening. X to the 5th means x times x times x times x times x. So if I multiply these together, I have x times x times x times x times, which is x to the 8th. Okay. So our rule is, if we are multiplying, what do we do with the exponents? We add them. Great job,
Is it the
guys.
same thing with a negative exponent? So say if it was x
Yep.
to the negative 3rd, it would be x to the 2nd.
Yeah, what you're saying with the 5th.
Yeah.
I knew what you were saying.
Oh.
Yeah, what?
He was saying if you combine it with x to the 5th. Yes, we'll do that in a second.
Alright.
So general rule, let's keep it neat and organized over here. I'm gonna say x to the m times x to the n. Once again, x is just a random base, m and n could be anything. But what you do is, the main thing about this is your base does have to be the same. So you can't you can't combine an x and a y. So they have to be the same base. So when you combine them, you keep the base and you add the exponents. And that's our 3rd rule. So we're just gonna do maybe 2 or 3 problems and then we'll wrap it up. We'll look at the problem set to kind of get it started with what you can, actually I need to look at it because I don't know where it started. And I know. And if I had it, that would be good as well. Oh, okay, yeah, you won't be able to do much with the negative. Because the negative and 0 ones, you don't really do those separately, they're kind of just attached. Okay, so let's just do 2 problems. Let's multiply. Once again, I'm just gonna kind of say it because I'm getting lazy with my writing of directions. When you give a final answer, there should never be negative exponents, so just as a heads up. Let's say, let's do a to the 4th, 3rd c. I'll do parentheses. Times a to the 6th, b to the negative 7th, c to the 5th. An awkward second. So here's what to not do. Don't go through and start flipping things. Then it just gets highly confusing because now you just have fractions everywhere. You don't flip until the very last step, till everything's combined together. So don't go and be like, oh, I see a negative, let's make that a fraction. Oh, it gets like way too confusing. So try to combine things first. So our main goal is we want to combine like bases. This is multiplication, right? If you have a set of parentheses next to a set of parentheses, we're multiplying. So here's what I do. Oh, God bless you. I just go through and look, I'm like an underliner, I like to organize myself. So I say, those have the same base. I'm multiplying them. So my rule tells me I add their exponents. So that will give me a to the 10th power. And I kind of just do that for each base. And I say, oh, this has a b, and that has a b. Let's add their exponents. And that will give me b to the -4th. Now let's do our c's. Please be careful here. Don't say there's no exponents. If nothing is listed as an exponent, we assume there is a 1. So whenever you see a blank exponent, always throw the 1 in. So now I can add those lovelies, and that would be c to the 6th. But we're not done yet because these other two rules are still in play. And this rule says, I don't want that negative, so I'm going to have to take care of that by flipping it. And I would get a to the 10th, c to the 6th, over b to the 4th as my final answer. So exciting. I'm just leaving that up for a second because I have limited space on my screen here. I always like these first ones. They're like delightful. It's when you start individually, they're all not bad. It's when you start combining them in the end that they can get a little bit confusing. But your main goal is, do I just understand the concept? If I see multiplication, I add an exponent. If I see a negative exponent, once I kind of combine everything, I flip it. If I see a 0 power, I make it a 1. If you can kind of get the basics of that, the other stuff should be easy peasy. All right, so I'm just gonna do one more, and I'm gonna have you guys do one wrap up. Let's do, I'm trying to make it hard, but it's hard to make it hard, guys. 3xy times 2x squared y to the -1st and times 4x to the -6th. So once again, with multiplication, sometimes you'll just see parentheses, sometimes you'll see the little dot. But we kind of know in general how multiplication is set up. And then we say to ourselves, okay, our first goal, we see some negatives, we're not going to deal with those yet. Our main first goal is just to combine stuff. Hey, what do I do with the 3, the 2, and the 4?
Can you add them to get multiply?
Right. So pretend this isn't here. And that's not there. That just literally says 3 times 2 times 4, right? So regular numbers, you just treat like regular numbers. You just multiply them because it's a multiplication problem. We only use this when you have exponents. So if you're not dealing with exponents, you just have regular numbers, you just multiply them. So 3 times 2?
6.
Is 6, sorry, there was no alarm across the hall. And 6 times 4 is 24. So now we're getting to some the bases that we're trying to combine with the exponents. So now we use our rule. If the base is the same, we're going to add the exponent. So I'm going to do the x's first. I got an x here. I got an x here. I got an x here. I'm going to add their exponents. Remember, this has a 1. Sometimes I just throw my 1s in to start just so I don't forget them. So I get 1 plus 2 is 3 minus 6 is -3. And then I have my y's. Once again, I threw a 1 in there because it was just y. And 1 plus -1 is 0. Ooh. So both of our rules come into play. I see a negative that I'm going to flip. and I see a 0, then I'm gonna change into a 1. So this gets flipped. And remember, I just kind of do that. Because if I turn something into a 1, it's just, if you multiply anything by 1, it's just whatever's left. So sometimes I feel like when you throw the 1 there, people get confused. So I end up with 24 stays where it is. And then X flips and becomes positive. That'll be your finding. I'll give people a second, and I'm just gonna give you one warm-up problem, my friends. Oh man, time flies when you're having fun, guys. We're on 10 minutes. Good stuff, good stuff. All right, so here's your wrap up. Can you try this one? It's gonna be multiplication, but those other properties may pop up. So be on the lookout. Let's say, we'll do 9 c to the 5th c to the -4 times -2 c to the -6 d to the 8. Okay, nothing too crazy. Hey guys, can you please multiply that right now? See what you get. All right, so let's look at it. This one's gonna shouldn't take too long. And then I just want to quickly look at that problem set just to kind of show you what I expect of you and kind of what it will do. So here's where people start to go crazy. You're like, okay, I'm starting to combine stuff, feeling good. I see C's, I see D's, I see numbers in front. I have 9 times -2. What is that?
-18.
Good job. Okay, -18. Well, I guess you go crazy in a second. Then we have C's. Add the exponents, that's C to the negative first. Remember, don't flip anything yet, you flip it at the last step. And then we got D's, and we got D to the 4th. I flipped negative exponents. Did anyone flip the 18? That's okay, I know, it's okay. In your entire life, when you see -18, have you ever made it a fraction?
No.
Then don't do it now. Okay. Only when the exponent is negative do you flip it. If you can just have a negative number, right? Let's just say, like, say -18. We've dealt with that our entire lives. Do not flip this. Only flip when the exponent is negative. So your final answer is -18 d to the 4th over c to the 1st. Yes, I wasn't trying to trick you. I just like to show you things that pop up. That can be a mistake sometimes. So I feel like people are really good with the exponents, and then like the regular numbers just like start to freak us out. Just treat them like regular numbers like you have your whole life. 9 times -2 is -18, and then you don't do anything to it. We only can move things or change things if they have exponents, so just as a reminder. There. And that's that, my friends.